Our today's topic is Gabriel Phthalimide synthesis. This synthetic scheme or reaction is particularly used for preparation of primary amines from primary alkyl halides. A very important points are there to note that this reaction is given only by primary alkyl halides. This reaction is not given by secondary or the tertiary alkyl halides and aromatic halides, aryl halides. So please keep this point in mind that this reaction is particularly given by only the primary alkyl halides and it is used for preparation of primary amine. Now let us look at the reaction scheme. As the name indicates, there is use of a very important chemical compound called as phthalimide. So the starting material is phthalimide, which have this structure. The phthalimide reacts with potassium hydroxide in alcoholic solution. So the reaction between the phthalimide and alcoholic potassium hydroxide leads to formation of potassium phthalimide. The potassium phthalimide, which is so formed, react with alkyl halide, whereby there is removal of potassium halide and there obtained an intermediate species which have this structure. This is called as N-alkyl phthalimide. The N-alkyl phthalimide then reacts with 2 moles of sodium hydroxide to give us the formation of disodium phthalate along with formation of RNH2, that is primary amine. So this is the overall reaction for the preparation of primary amine through the Gabriel Phthalimide synthesis. The starting material is this cyclic compound which is called as phthalimide, and this compound is acidic in nature. There is presence of this acidic proton on this nitrogen. So we can write this way. There is a bond between nitrogen and hydrogen. So when potassium hydroxide is reacted with phthalimide, this hydroxide ion react with this acidic proton and there is release of a water molecule. This electron pair of this bond are left behind by the hydrogen and are taken by this nitrogen, which is electronegative element. So nitrogen now acquire a negative charge. So this species is called as potassium phthalimide, where the nitrogen bears the full negative charge. So whenever there is a negative charge on nitrogen, that means it behaves as nucleophile. So this nucleophile attack on the carbon of this alkyl group. This is a very familiar reaction to us. The nucleophile attack on a carbon and substitute the another nucleophile. So just have a look at this molecule R and X. There is a bond between carbon and halogen. Halogens being electronegative attract the electron pair towards themselves, so that's why they will acquire the negative charge while the alkyl group will acquire the positive charge. So this phthalimide anion attack on this carbon and substitute the halogen. So this is the example of nucleophilic substitution reaction, and it is SN2 type of reaction, which is a bimolecular nucleophilic substitution reaction, which is chiefly given by the primary alkyl halides. So when the substitution takes place, the alkyl group is get attached with the nitrogen. The halogen, which is liberated out as halide ion, then will be in ionic bond with potassium to form potassium halide. So the species which is obtained here is called as N-alkyl phthalimide, because the alkyl group is now attached on the nitrogen of the phthalimide. This N-alkyl phthalimide then on reaction with 2 moles of sodium hydroxide gives out the formation of the disodium phthalate and primary amine. Now look how this conversion takes place. The 2 sodium hydroxide molecules give 2 hydroxide ions. So we have 2 hydroxide ion, 1 hydroxide ion over here, and we will write down another hydroxide molecule over here. As we know that the hydroxide ions are the nucleophile, so this hydroxide ion will attack on this nucleophilic center here, like this way. The hydroxide ion with a pair of electron tends to make a bond with the carbon. So there is a partial bonding formation between this carbon and the hydroxyl group. So when this bond is being formed, these electron pairs are more shifted towards the nitrogen. To grab this electron, this hydrogen will migrate over the nitrogen. So one hydrogen migrates from this hydroxyl group over here, and another hydrogen will migrate over this nitrogen. So in this way we will get the bond breaking between this carbon and nitrogen and the bond breaking between this carbon and nitrogen. Both the hydrogens will then attach on the nitrogen to form RNH2. So we will get the formation of RNH2, which is primary amine. When the oxygens liberate out the hydrogens, they will acquire the negative charge. So here we will obtain this disodium phthalate ion. Initially the phthalate ion is formed, which remain in combination with the sodium ions, which are positively charged species. So that is all about the mechanism of this reaction. Let's look at a single example of this reaction. Say we start with this alkyl halide CH3, CH2, CH2, Cl, which is called as chloropropane. It is also called as N-propyl chloride. In IUPAC nomenclature, it is called as 1-chloropropane because it is carbon number 1, 2, and this will be 3. So 1-chloropropane, when reacted with potassium phthalimide and then with 2 moles of sodium hydroxide, there we obtained CH3, CH2, CH2, NH2, which is called as propanamine. More especially, it is 1-propanamine, which is example of primary amine. So starting with this primary alkyl halide, we will get formation of this primary amine. So that is all about the Gabriel Phthalimide synthesis. Hope this video is of great benefit for you people. Please like the video, share it, and don't forget to subscribe. Thank you.